Good morning, my name is Joe. We're going to take 5 minutes and look at vectors and vector addition. Now, let's see if I can get this to zoom in a little bit for you. All right. Okay, so a vector has a direction and a magnitude. So let's pretend that the dot is you, and we know that you're moving to the right at 2 meters per second. Okay? We also know that with respect to an outside observer, you're also moving up at 2 meters per second. And what we want to do is find out the resultant velocity of these two vectors. Knowing that you're moving to the right at 2 meters a second and you're moving up at 2 meters a second, how fast and in what direction are you actually moving? So we've drawn these two vectors in a method that is called tip to tail. And what that means is we've come to the tip of this vector, we've started the tail of the next vector, drawn to the tip. And we know that these two vectors are perpendicular because one is directly to the right, one is directly up. So there's a 90-degree angle here. Completing the triangle with a line that represents our resultant vector is going to allow us to use some very basic triangle skills to solve for this resultant vector. In this case, we're going to use Pythagorean theorem. Pythagorean theorem says that if this is side A, and this is side B, and this is side C, then A squared plus B squared equals C squared. Now, if we want to solve for C, we can use simple algebra to rewrite this expression and say that C, the length of side C, is equal to A squared plus B squared and the square root of that quantity. Now, in this case, we've got A, which is 2. 2 squared is 4. Same thing, 2 squared is 4. 4 plus 4 is 8. So C is actually going to be equal to the square root of 8. Okay? Now, we know by symmetry that because these two sides are equal, these two angles also have to be equal. And if those two angles are equal, we know that all triangles have 180 degrees within them. This is 90 because it's perpendicular. These two have to be even, so we take the rest, which is another 90, divide it by 2, and we know that both of these angles are 45 degrees. So, using these two vectors, we've determined that the resultant vector has a magnitude of the square root of 8 meters per second and is 45 degrees above the horizontal. So let's look at a practical application of what we just did. We'll keep it very, very simple. And we will continue to use two vectors that are perpendicular to each other. Let's say that we have a river. Right? Okay. And, okay. So we've got our river, and our river is traveling, it's flowing rather, up. Okay? So the positive y direction is up. Okay? And the river is flowing at, let's say 1 meter per second. It's an arbitrary number, but it'll work just fine. And then let's say you have a boat. See if I can draw a boat here. Ooh, boat. Okay. There's your boat. Now your boat sets off from shore. Okay? And it proceeds to the right, let's say at 3 meters per second. It's a power boat. You're not having to row. Should be pretty easy. What we need to determine is where will this boat end up over here? Will it end up directly across? Will it end up down here? Will it end up here? I don't know. Okay. So using the same method as before, we've got a vector to the right of 3 meters per second. We've got a vector up of 1 meter per second. Okay, and the reason for the vector up is because as soon as this boat leaves the shore, it's moving under its own power this way, but the water itself is going to carry it this way because all water is moving up in the plane of this board. Just as before, we're going to complete this triangle. That's going to give us our resultant vector. We're going to have an angle here that we don't know. Call it theta. We know that the river is running straight up, so it's perpendicular to this boat that is going to be moving straight across. And we're going to find out what that vector is. So, same steps as before. We know that c is equal to the square root of 1 squared plus 3 squared, right? C is equal to the square root of 1 plus 9. C is equal to the square root of 10. Now you can use your calculator and determine a decimal value here that is going to be easier for you to work with later, but for now we're just going to use c is equal to the square root of 10, which is going to be a little larger than 3. The square root of 9 is 3, 4 squared is 16, so it's going to be somewhere between 3 and 4. Closer to 3, significantly closer to 3. Okay, now, the real question here becomes, what is this angle? We know that we're going to be moving in a path that is above the horizontal, because that's the way our stream is taking us, but how many degrees off are we going to be? Okay, we also can now see, based on the direction of this arrow, that we're actually going to land up in here somewhere. Now, to find that angle, you're going to have to use trigonometry. You're going to have to use trig ratios. And unfortunately, our 5 minutes for today are up. But next time, we'll take a look at trigonometry and see if we can determine what that angle is. Anyway, I hope that you found this beneficial, and if you ever need to learn more about vector addition, feel free to continue watching these videos.